So as I said in previous class that VRF represents one virtual router and forwarding, right? VRF. So today we are going to perform all practicals of VRF lite. Means that we will be implementing VRF over here without MPLS, and if you are implementing VRF without MPLS, which is called actually VRF lite. So this time let me do one thing. Let me allocate IP address is in this manner: 12.1.1 at the end of R1, and then 12.1.2 at the end of R2, and then 23.1.2 at the end of R2, and then 23.1.1.3 at the end of R3. Fine. So in this way we are having here this connectivity, this reachability, right? Now what can we do? Let's say that R1 is having some prefixes in its lane 10.1.0/24, or forget about it, right? Let me just do this implementation first, and then I will show you that how can you create VRF, because I have already explained you that what is the meaning by VRF. So on its FA0/0 IP address is going to be 12.1.1, and then we can move on R2 as well, and on R2 of interface FA0/0, fine guys. Now you see on R1 I will also create some loopbacks as well, like 10.1.1, loopback 2, 3, 4, 5, 6. Check it out. So we are having all this configuration, right? So because we are having all this configuration over here, as you can see this, and all of them are the part of global routing table, as you can find all of them in its global routing table itself, right? Like if you say show IP route, it means it will show you, it will display you global routing table, right? So this is your global routing table, and all of the interfaces are part of global routing table. Fine. Now if you want to create any VRF over here, let's say that you want to put them into different routers, like you want to create some virtual routers onto R1, and then you want to put these interfaces into different routers, I mean into different VRFs. You can do that. Like to create VRF, command is very simple: IP VRF, and then you can create it with any name. Let's say that I have created one VRF with the name of test. Then you can create another VRF, IP VRF, with the name of Cisco as well. So here I have created two different VRFs. Show IP routes are still part of global routing table. There is no change at all, because we have not configured any interface in any VRF. So if you say show IP VRF, so it will show you that how many VRFs are existing on your device. So here we are having two VRFs available. One is Cisco, another one is test. One is Cisco, another one is what? Test. So you can see that they do not have any single interface in that. See, under interfaces we do not have any interface. It means there is no interface which is member of any VRF. Now let's say that I want to put first 3 loopbacks in VRF test and last 2 loopbacks in VRF Cisco. You can do it very easily. Not only loopback, even you can also put physical interfaces into your VRF, because I mean like commands will remain same. So go to interface loopback 1, and then if you want to put this loopback 1 into VRF test, then the command would be IP VRF forwarding and then your VRF name. IP VRF forwarding and then VRF name. Just press enter. Once you will change VRF membership, like if you are going to put any interface into any VRF, or if you are going to remove any interface from the VRF, then IP address of that interface will always be removed, and it's compulsory. It's needed actually over here. You know why? Because one VRF represents one router. If you are placing one interface from one VRF to another VRF, means that you are placing your interface from one router to another router. However, they are virtual routers, but still they are, I'll call them as a router, right? So if you are going to place your interface from one router to another router, might be that any existing interface in that router was already having the same IP address. Is not it? How can you say that okay, that router do not have the same IP address? Hello?
Yes.
Might be possible that like this VRF test was already having, it was also possible, right, that it was having the same IP address configured onto its own interface. Then how will it be possible for 2 different interfaces to contain same IP address? So there is a rule that whenever you will configure any interface into any VRF, or if you remove any, if you remove your VRF from any interface, then it will become the member of global routing table, right? So every time your IP address will get removed from your interface.
So will this command work if you use interface range loopback 1, 2, 3 to take the range command?
Yeah, it should work. It should work in range also. It should work. Fine. So now you have to allocate your IP address. And now one more thing. While you are allocating VRF to any interface, or you are putting your interface into any VRF, it will remove your IP address and it will display only that IP address which has been removed from your interface, but it will not display its subnet mask. So now the problem is that in T-shoot over there, in lab examination or in production network, if you are going, or if you are thinking to put your interface into any VRF, then definitely its IP address will get removed, but along with that it will also display IP address only. I mean, it will show you that okay, this IP address has been removed, but it will never display you subnet mask. If it doesn't display you subnet mask, and then again you have to allocate IP address along with subnet mask, then how will you define that okay, what was the previous subnet mask onto this interface? How will you come to know about that? That is why it is always recommended that before putting your interface into any VRF, or before removing your interface from the VRF, check its subnet mask as well as IP address. However, IP address will still be displayed over there, but check its running config so that you can come to know about its subnet mask. Have you understood it or not? So now say IP address 10.1.1, because I knew it, right? Loopback 2, IP address will become now 2.1, loopback 3, and test, and then IP address has to be configured, right? Then go to loopback 4, put in VRF Cisco, IP address will be 4.1, then loopback 5, and then IP address will be, Yes, 5.1. Now show IP interface brief. If you configure this command, still it will display you all of the interfaces. There will not be any problem. But if you say show IP route, what is this? This is your global routing table. So this time you were having only one interface onto this device, into this global routing table, because all remaining interfaces you have already put them into VRF, into different VRF, right? So as I said earlier on, that one interface can be member of either global routing table or of any VRF, and you can put your interface maximum into any one VRF. Yeah, if you are using sub interface, then that is different thing, because for each sub interface, you can put each interface, or each and individual interface into sub interface. Actually, you can put each and individual sub interface into different VRFs. For different sub interfaces, you can have different VRFs. Have you understood it or not?
So they work like a virtual
Router now. Now, if you wanna see routing table of VRF test or Cisco, of course there will be a separate routing table now for each VRF, right? This is global routing table. In it now you are having only FA0/0, because we didn't put this FA0/0 into any VRF.
What about the memory consumption?
What?
Memory consumption.
Of course, it will be just now twice, thrice. It will be depending on the total number of routes and all. Of course, CPU utilization will be higher. CPU utilization will be higher. Memory utilization will be higher. So that is why what I said earlier on to you, that VRFs will be configured at the end of service providers in most of the cases, and all those devices will be having very good hardware configuration. So now you see show IP route. So it is showing you only global routing table, and then if you want to see routing table of VRF test, then the command will be show IP route VRF test. So it will show you routing table of VRF test, you see. Right? And then if you want to see routing table of VRF, remember, prefixes cannot move from one VRF to another VRF automatically. Traffic cannot move from one VRF to another VRF automatically. Traffic, prefix is nothing. It cannot move from one VRF to another VRF. Right?
After enabling routing, even after enabling routing.
Of course. By default, prefixes cannot move from one VRF to another VRF, right? Now the question is that why should we implement VRF into our own network? Remember, let's say that this is okay. Let me design this network now in different manner now. Let's say that you are having this type of diagram actually, where this is service provider, this is Cisco's site A, this is Cisco site B, this is Accenture site A, this is Accenture site B. Fine. Now Accenture site A must be able to communicate with site B, and Cisco site A must be able to communicate with site B. Cisco site A must be able to communicate with site B. Now, because this is only data lease line, I mean these are not internet connections actually. That's why I didn't specify ISP over here. So they are having point-to-point connections which either with each other. I mean this Cisco as well as this Accenture in between their sites. Fine. Now let's assume that Cisco is using private networks over here and Accenture is also using private networks. Cisco in another site also using private networks. Here Accenture in site B also they are using private networks, and might be that they are using same private networks. Now if you are using a common router over here at the end of service provider, right, for all these customers, same prefixes are coming from Cisco site A, same prefixes will come from Accenture site A. Now this service provider router has to define its best path because they are coming onto same prefix length. Are you getting my point or not? So it will define its best path. Let's say that same prefix is advertised by Accenture site A 192.168.1.0/24. In same manner, Cisco site A is also having same network over here. And also it is advertising it towards service provider, right? Now service provider has to define its best path. It will define it via either Cisco site A or towards Accenture site A, right? Any one path will be best path. And if it is performing equal cost load balancing, then again CEF is there, Cisco Express Forwarding. Accordingly, then it will perform load balancing, right? Now Accenture site B wants to send some traffic towards site A, I mean towards this subnetwork. Now it will send this traffic towards service provider. Now service provider can send this traffic either towards Cisco or Accenture. It can go anywhere. If it is going towards Accenture, well and good. If it is not, it is going towards Cisco, then what will happen? Now to solve this problem, service provider has to use two routers now. Has to use two different routers, two physical routers. One physical router for Cisco, one physical router for Accenture. How many customers are there for a service provider over there? Like 1,000 or more than that. So would it be possible for service providers to place 1,000 different routers, physical routers?
This is cost effective.
That's one. This is the problem now. To solve this problem, now we are having VRF. You get my point? You can break your physical router into multiple logical routers. Have you understood it or not?
Yes.
See, you cannot restrict your customer that use this prefix, you do not use this prefix, never. Because all customers and all users are free to use any private network in their own networks. So if you are having that type of situation, then definitely you will get so many problems in your network. If you are not able to understand it, please let me know. I can explain it to you once again.
But in general, they're using a redundant router.
Where? Service provider?
Yeah.
Of course, there will be too much redundancy, but right now I'm just trying to make you understand in this manner only. Have you understood it now? So basically, like if your customers are using same prefixes, then problems will occur. And to solve that problem, here we are having VRF. As I said that by default, prefixes cannot move from one VRF to another VRF, or even traffic data cannot move from one VRF to another VRF automatically. Have you understood it now? Great. Let's implement this diagram in this manner only. this switch L2 switch is placed at the end of service provider only. Right. So there are two customers for this service provider for this service provider. One is Cisco, another one is IBM. And this is not router, right? This is what? Layer 2 switch. This is working as a layer 2 switch. So this switch cannot perform routing, and I will not do, even I will not configure any single IP address onto that, right? Fine. So let's say that for this service provider I'm going to use 10.1.0/30 subnetwork in between Cisco site A and service provider, right? In between Cisco site A and service provider. In between Cisco site B and service provider, I will be using 20.1.1.0/30. In between IBM site A and service provider router, I will be using 30.1.0/30. And in between IBM site B and service provider, I will be using 40.1.0/30. These are their WAN IP addresses actually. In this way, I'll define their WAN IP address. Now, in the lane of Cisco site A, you are using 192.168.1.0/24 to 192.168.5.0/24. Same prefixes you are using in IBM site A. Then Cisco site B is using from 6.0/24 to right. Have you understood IP addressing over here? Like WAN IP addressing as well as, right? And because here I'm using this switch as a layer 2 switch, and I'm having only one interface at the end of service provider router, so I have to create sub interfaces for each customer, for each site. So that is why I have to put them into different VRF, into different VLAN, right? Into different VLAN. So what can I do? I will use for Cisco site A as VLAN 10.
So even on our end, we use the same.
VLAN 30. For Cisco site B, I'll be using VLAN 20. And for IBM site B, I will be using VLAN 40. Fine. And then because here this interface has to carry multiple variance information, so it has to be trunk code. It's kind of like, do you remember we performed router on a stick? It will be something like that. And here, because we are having two different customers, so how many VRFs will be required at the end of service provider router? Two. One is Cisco, another one is what? IBM. So I'll be creating two VRF at the end of service provider router, right? And two sub interfaces will be part of VRF Cisco, and two sub interfaces will be part of VRF IBM, because I will create four sub interfaces at the end of service provider router, because you are having four different VLANs, four different subnets, so you have to create four sub interfaces at the end of service provider, right? Two VRFs will be there because there are two customers only. You will put two sub interfaces into same VRF and another two sub interfaces into same VRF. So I'll be doing that. So first of all, let me see. There will not be any configuration related to VRF at the end of customer. So let me do the configuration at the end of customer first. So this is Cisco site A now. First of all, interface FA0/0 is going to use 10.1.2/30. Then loop back 1. Loop back to 3, 4, 5. Do show history. Fine. After doing this configuration, let's move on site B, Cisco site B. Let's configure this router as well. First of all, it's FA0/0. Let's say its IP address is 20.1.2 on/30. Loopback 1 is having like 6 dot. I'm going to say no CDP run, otherwise it will keep on to show me that okay, blacks in mismatch and all these things, like here also. So I'll say fine. IBM site A, let's configure it as what? Yes, I'll copy the two tabs. Interface FA0/0 is going to be used and I'll copy it from now Cisco site A. I mean all loopbacks will be from there only, so I'll copy it from here to there. Fine. And now I'll take console of site IBM site B, right? So at the end of customer, you don't need to do any extra configuration related to VRF. 40.1.2/30. I'll move on simply Cisco site B, and then I'll copy loopbacks. I have done that. I have done configuration. I mean, I have allocated an IP addresses at the end of. Now let me configure this switch, layer 2 switch first, and then I'll do configuration at the end of service provider router. So as per this diagram, I have to do this configuration actually. That's fine. as you know that it is going to be in VLAN 30, it is going to be in VLAN 40, it would be in 20, and this would be, and this would be trunk. Say no CDP run. Fine. Now first of all you have to create your VLANs, like VLAN 10. Fine. Now you have to provide VLAN membership. I have added the module of switch onto this router, right? I have added module of switch onto this, and you can also see these VLANs like show VLAN. Now go to interface FA1 by 0, switch port, mode access, switch port access VLAN 10, 1 by 1, switch port mode access, switch port access VLAN 30, interface FA1 by 2, switch port mode access, and switch port access VLAN 20, then interface FA1 by 3, switch port mode access, switch port access VLAN 40. Then go to FA1 by 4, switch port trunk encapsulation is switch port mode trunk. That's it. Show interfaces trunk. This is your trunk port. Understood? And then show VLAN switch brief.
सर आपने इसमें स्लॉट कौन सा यूज करा है एलसी स्विच पे?
Switch. I'll show you that how can you add it. Fine. After doing this configuration at the end of switch, now I'm going to remove this switches console. I don't need it anymore. Then let's have the console of service provider router now first of all. And now accordingly I have to do this configuration now SP router. As you know very well that first of all go to FA0 by 0, say no shutdown, and as well as say no IP address, and then just come outside, create your sub interfaces, and before that it will be good for you to create your VRF. So I have to create two VRFs now, IP VRF, one is Cisco, and then IP VRF, one other one is IBM. Now let me show you, show IP VRF. So there must be two VRFs now, Cisco and IBM. There is no interface member of any VRF yet. I'll put them, right? I'll put some sub interfaces into these VRFs. I'll create sub interfaces. See, interface FA0 by 0.10 for VLAN 10. For VLAN 10, I'll create sub interface .10. So first of all, the command will be encapsulation .1q VLAN number 10. Then say IP VRF forwarding, because this VLAN 10 is allocated to Cisco, right? So I'll put this sub interface into VRF Cisco. Then IP address should be from this range only, which is used for VLAN 10, right? 255.252, right? Fine. Any problem? Then create one another sub interface FA0 by 0.20 for VLAN 20. Say encapsulation .1q 20, and then say IP VRF forwarding is what? Sorry, Cisco. IP address will be 20.1.1 and slash right, and then just come outside and say interface fast ethernet 0 by 0 dot encapsulation .1q VLAN number 30, and then say IP VRF forwarding IBM. IP address will be 30.1 dot on slash, then go to FA0 by 0 dot encapsulation .1q VLAN number, IP VRF forwarding IP address will be 40.1. Now you see show IP interface brief. I have configured 4 sub interfaces over here, right? But if you say show IP route, no route, because there is no interface available in its global routing table. How many VRFs are there now? 2. Cisco and IBM. Cisco is containing 0x0.10, 0x0.20, whereas IBM is containing 0x0.30 and 0x0.40. So now if you say show IP route VRF Cisco, you will get all prefixes of VRF Cisco over here. Then show IP route VRF IBM. Right? After doing this configuration, now if you go to Cisco site A, and from here if you want to try to communicate with 10.1.1, of course it must be able to communicate with that, but it cannot communicate with like 20.1.1.1 because it does not have that route to reach that, right? Like you can perform lookup over here, right? But if you move on SP router, and from SP router if you want to try to communicate with, you will not, because by default it will look at its routing global routing table to forward these packets. If you wanna ping anything inside VRF, because here at the end of service provider we are using VRF, so in ping command also you have to specify your VRF, like ping it was, and then say sorry 2. Even you cannot ping yourself without specifying VRF because it will look at its global. However, this interface is not part of global routing table anymore. Understood? So if you want to communicate with yourself as well, then you have to say ping VRF Have you understood it? So on that device where you have configured VRF, every time you have to specify your VRF in all types of task. Now you can ask me, sir, then how was it possible to communicate it from Cisco site A without specifying VRF? Because VRFs are having local significance. See what is happening actually. Like Cisco site A, because it is having this network as directly connected, it will give it to the switch will forward it out from trunk port trunk, and then SP router will receive it onto his sub interface, and that sub interface is already member of VRF. It means SP router will receive that ICMP echo request inside VRF itself, so it can provide echo reply very easily because it received echo request inside VRF. Hello?
Yeah.
And it was already having that interface in that VRF, so it given reply immediately. Fine guys. Now after doing this configuration, let's say that we want to configure routing. So to perform routing for Cisco and for IBM, you have to configure routing protocols. You have to configure routing protocols now, otherwise Cisco site A will not be able to communicate with Cisco site B, and IBM site A will not be able to communicate with IBM site B. To achieve that, you have to configure routing now. You have to configure routing protocols in between service provider router and Cisco site A, and also service provider router and Cisco site B. Now what do you want to use what routing protocol you want to use in between service provider router and Cisco sites? EIGRP. So do you want to go for EIGRP first or RIP? EIGRP. Okay, let's start then EIGRP named mode, right? I'll be doing this configuration with using EIGRP named mode. So to do that, actually just go to, first of all let's configure the service provider router, right? And you see to configure this service provider router, it's very easy. Router yes, but it will not support named mode actually, because I'm using iOS 12.4, so I have to do it in classic mode only, right? So say router EICRP, let's say here I have said what, 1, or you want to take something else like 100. Let's say we are using here. Then create address family. Do you remember that we created address families in BGP? Now address families are also supported in EICRP, RIP and everywhere for VRFs. For VRF. So address family IPv4 VRF, and VRF name is what? Cisco. Make sure that VRF name should be correct. The spelling must be same.
Case sensitive.
Of course. Right? Now inside this address family, enable EIGRP onto your sub interfaces. And as you know that we were having 10.1.1 configured over here, as well as 20.1.1 configured over here. So now you will see that EIGRP will get enabled onto these two sub interfaces now inside VRF Cisco. To see that, actually to check it out, there is a command like show IP EIGRP VRF is what? Cisco interfaces. That's it. Show IP EIGRP VRF Cisco interfaces. So this command will show you that inside VRF Cisco on how many interfaces or on which interfaces EIGRP has been enabled. So has EIGRP enabled now? Wow. Let me show you. Show IP ICRP Cisco topology. It does not have anything over here. Oh,
Customer side.
no. Actually, EICRP is not functioning right now because EICRP have not picked its router ID. So router EICRP, I think it was 100, right? So say EICRP router ID is 1.1.1 over here. Now let me show you. Still it is not showing me anything over here. You have to define your autonomous system inside address family itself. So what do you want to use? Do you want to use the same that you configured globally? See here, as you configured your AS here globally, it will not create any difference. For our neighbors, it will not be working actually. The autonomous system which you will define under address family will be in working mode actually. So globally I configured 100. Here I'm going to take it as 1. And now it must be able to show me that, see. So under address family you have to define your AS number as well. So here now if you say show IP protocols, it will show you only and only globally configured. But if I want to see that EICRP1, then say show IP protocols VRF is what? Cisco. Then here for now, now it will show you that it is running EICRP1. Hello.
Yeah.
So this time you are running EICRP AS number 1. Now you have enabled EICRP onto both sub interfaces onto service provider router. You do one thing now. Move back again on Cisco site A and configure router EICRP. Which AS number? 1, not 100, right? And then say not assembly network 000. It must form now neighborship, right? And in same manner I will move on Cisco site B, router EICRP1 not assembly network 000. Even you could use this network 00 command at the end of service provider as well. like in this way. Let me show you. Router EICRP 100 address family IPv4 VRF is what? Cisco, and then you could say network 000, because EICRP will get enabled only on those interfaces which are the member of VRF Cisco, right? So we could also use this command as well, but this time I'm not going to use it. Do show run pipe section router EICRP. Check it out. This is your configuration. This is globally configured, and this is your this is configuration for VRF. Fine. Now you do one thing. Move on Cisco site A. On Cisco site A, you must be able to see all prefixes. Is not it? Some of them are directly connected, and some of them have came here up via EICRP from 10.1.1, right? Because it is having neighborship with, because they were in same VRF, so of course within a VRF they can communicate with each other. They can also exchange their prefixes with each other. So now if you wanna try to communicate with 6.1, of course you must be able to do that. Even if you wanna take telnet of site B, do one thing, say enable password Cisco line VTY02 for password from site A, say telnet how traffic is going from here to there. You have to understand it now, right? See, packet will be formed over here, and in that packet source, let's say source is what? Even you can put source your own loopback as well, like do one thing, ping when source is your own loopback, no problem. So if you are pinging in this way, at that moment source is going to be tell me 1.1 and destination was 6.1. Fine. Because this site is already having that route available in its own routing table, so it will transmit it out from FA0 by 0 towards 10.1.1.1. So now this packet will be received by this L2 switch onto its 1 by 0, and this is member of VLAN 10. Now it is having this trunk port, it will transmit this packet out from this trunk port. Finally this SP router will receive this packet onto subinterface FA0 by 0.10. Are you getting my point or not? And that is the member of VRF Cisco. That is the member of VRF Cisco. So it received this packet in VRF Cisco. That is why it will perform routing lookup in VRF Cisco itself. So whenever this SP router will perform lookup in its VRF Cisco itself, so IP route VRF, it will come to know that how can I reach 6.0 network via 20.1.2. Right, and it is reachable via fast Ethernet 0 by 0.20. So once again it will transmit this packet out from this sub interface, right? Sub interface, and because whenever this router will send this packet out from this sub interface, it will add the tag of VLAN 20. So whenever L2 switch will receive this packet back onto trunk port, it will be having tag of VLAN 20. Then it will check that which interface is the member of VLAN 20. So of course it is F1 by 2. So it will send this packet out from F1 by 2, and finally it will be received by Cisco site B. Any problem? And in same manner traffic will come back from site B to site A. So this time SP router is not performing lookup in its global routing table, it is performing routing lookup in its VRF. So in this way you can configure EICRP for any VRF. So you have to create address families, and under VRF whatever you will configure, your AS number will be applied or will be in use actually. So if you configure now AS 100 on Cisco site A, will it be possible for it to form neighborship with SP router? No. because SP router is using AS number 1. Now what do you want to use for IBM, RAP or something else? Let's configure RAP now, right? For IBM, for customer IBM, for both sides, right? So let's do one thing, move on SP router first of all. This is SP router. Say router RAP. This is that you configured globally, right? If you want to configure it for VRF, then you have to create VRF is what? Say version, not network, give network command only.
सर ड्रेस फैमिली के बिना नहीं हो सकता VRF.
Because most of the time, like in RIP, you can configure maximum one process. It's not it. So for VRF you have to create address families in all, whether it is ESGRP, RAP, OSPF, or whether it is BGP. Yes, in OSPF it is not necessary. In version 2, even you will not get that option to create address families for VRF inside OSPF in terms of version 2. But if you are configuring OSPF version 3, then you can also create address families for your VRF as well. So network 30.0.0 and 40.0.0.0, because if I am saying 40.1.1.0, then again it will convert it back 40.0.0, so there will not be any, of course, difference, right? So this time you see show IP RIP VRF name is what? IBM. So it is having, see, it means RIP has been enabled onto these interfaces now, right? Now do one thing, go to IBM site A, and onto IBM site A, do one thing, say router, tell me RIP not summary network, okay, version 2. In same manner, move on site B, router B version 2 not summary network, you have to do wait. See, all of them have came via RIP. See, even if you check now routing table at the end of service provider, it will amaze you actually. Like, see, show IP route VRF Cisco, same prefixes. VRF is also having same prefixes. Except WAN IP addresses, right? And then you see your traffic will never get mismatched. You know how? Like if you are going to IBM site A and if you try to communicate with 6.1, when your source is, and how can you confirm that? Are you really communicating with IBM site B or Cisco site B? How can you confirm that? We can take telnet. Like we can enable telnet on IBM site B as well. Enable password is what? Cisco line VTY 024. Password is what? Cisco. Now you do one thing, move again back on Cisco site A and take telnet of 192.168.6.1, same IP address, right? So we have accessed what? Cisco site B. And now from IBM site A, I'll take telnet with using same IP address 6.1. Cisco, IBM site. So how is it going now? See, let's say source is what?
1.1.
This time it was like 30.1 because in source it was taking its exit interface IP address, right? So it was 30.1.2. But you can also think that okay, it is what? 1.1 destination was. So it will send it out from this interface now because it was learning this 6.0 on this interface from its neighbor 30.1.1.1. As you can check its routing table as well on site A. So IP route, it is receiving all these prefixes coming from 30.1.1. So it will now switch to a layer 2 switch will receive it on this F1 by 1, which is member of VLAN 30. Then it will send it out from the trunk port. Now SP router will receive it onto sub interface .30, which is member of VRF IBM. Because it received this packet in VRF, IBM, so it will perform routing lookup in VRF IBM itself. So if you perform lookup in VRF IBM, see this is for the IBM, so this 6.0 is reachable via 40.1.2 and out from FA0 by 0.40. So it will send this packet out from FA0 by 0.40 with tag of VLAN 40. So whenever layer 2 switch will receive it back on trunk port, it will be with the tag VLAN 40. So now in VLAN 40 it is having only one interface, which is F1 by 3. So it will send this packet out from this interface only. So now service provider router will never get confused. Even for both sides you can also configure multiple, different routing protocols, and then after you will require to perform RAID distribution. Is not it? Are you getting my point or not? Like here, what can you do? You are already running EICRP. Let me do one thing from service provider. Let me remove this RIP as well as EICRP. Say no router RIP and no router EICRP 100. For remove it from all. Remove it. No router EICRP 1. From Cisco side B as well. Say no router EICRP 1. From IBM side A, say no router RIP. From IBM side B also no router RIP. Now SP router is there. This time for Cisco itself, I'll be using two different protocols now. What do you want? OSPF, EICRP. So do one thing now on SP router. Let's say in between SP router and site A, I'll be using OSPF, and between SP router and site B, Cisco site B, I'll be using EICRP. Have you understood it or not? So here I'll be using OSPF 1 area 0, and here I'll be using EICRP 10 this time. Globally I can take anything, so I will move on SP router first of all, and then I'll say router OSPF 1 VRF. Here there is no address family in OSPF version 2, so along with process ID you can call your VRF. That is why we were having process IDs in OSPF, because for each VRF there will be a dedicated process ID of OSPF. So VRF, its name is what? Cisco. Router ID we can allocate like 1111, and then because we wanted to configure OSPF for site A only, so I'll say network 10.1.1 and then 00 area. Fine, that's enabled now. So let me show you. Show IP OSPF interface brief. This is enabled. Process 1, and process 1 is associated with VRF. Hello, this is process 1, and process 1 is associated with VRF Cisco. Then you do one thing, say router EICRP 1000 or 10,000, whatever it is. Say address family IPv4, VRF is what? Cisco, and then say autonomous system is what? 10, and then say not auto summary, and then network 20.1.1 and then 0000. Fine guys? Hello?
Yeah.
And then you can also check it over here, like show IPICRP VRF is Cisco interfaces. So it will show you that on .20 EICRP 10 has enabled. Then you can move on Cisco site A. On Cisco site A, say router OSPF 1. No, sorry, net router ID is, you can take anything like 22222 over here, or 10.10.10.10.10. Then network 00, tell me. Area will be 0. Neighborship okay now. Then on Cisco side B, I'll be using router EICRP 10, not a summary network. Fine. Now thing is, SP router will start to receive all prefixes from both sides of Cisco. So IP route VRF Cisco, check it out, all routes are coming. Some of them are coming with the help of OSPF and some of them are coming with the help of EICRP. OSPF is advertising loopback onto /32, that is why you can see that some prefixes are coming on 32, right? But you will see that site A will still not be having routes coming from site B, and site B will not be having routes coming from site A. As you can move on site A and you can check its routing table, you will not find anything over there, because by default prefixes cannot move from one routing protocol to another routing protocol. So this time you have to perform redistribution. To perform redistribution onto service provider itself, you do one thing. First of all, let's redistribute OSPF into EICRP. So say router EICRP, it was I think 10,000.
Yeah.
Globally it was 10,000. Then say address family IPv4 VRF is what? Cisco. And then say redistribute what? OSPF 1 VRF, name was Cisco itself. And then do not forget to define your metric 1544 0 255 1 and 1500. To check your topology table on SP router itself, just to confirm whether redistribution was done successfully or not, command would be show IP EIGRP VRF, name is Cisco, and then topology table. So see, prefixes have been redistributed over here, right? Like 4, 1, 2, 3, all these things. You see 1, 2, 3, all are redistributed. Fine. So it means that now you can find all these prefixes on site Cisco site B. Check it out. Understood? So in this way you can perform redistribution from from OSPF into EICRP. Move back again on SP router and this time perform redistribution from EICRP back into OSPF. Router OSPF 1 and VRF name was Cisco. Then say redistribute what? EICRP what? 10. And here you don't need to define your VRF because you are already inside VRF. So it will check that how many prefixes are coming via EICRP inside this VRF, and it will redistribute all of them, right? And then you have to add subnets keyword. Then you can also define your metric type 1, and then you can also define your tag like 100. Then you can move back on Cisco site A. You must be able to see them as external type 1. You see. And now again you can try to communicate with that telnet 192.168.6.1 Cisco. Fine. Then if you want to use now BGP, you can also use BGP. So at the end of service provider, what do you want? I mean, which AS you want to configure?
200.
But here, let me tell you. Okay, you are okay. Let's say that we want to configure this time BGP in between IBM site A and SP router. So at the end of IBM site A, I'll be using AS 65500, and at the end of service provider router, I'll be using BGP AS 100. And then in between, what do you want? In between SP and IBM site B, what do you want? BGP itself or something else? Let's say BGP itself. BGP AS 65500. So that we will also require to configure allow AS in command. Allow AS in command. Wow. So move on SP router. Now if you are going to call your VRF into BGP, then in VRF you have to configure one another thing which is known as this RD. If you are going to call your VRF into BGP, RD is mandatory. RD is stand for route distinguisher. Route distinguisher. And what is the meaning by route distinguisher? Which will be responsible to differentiate your prefixes. During MPLS, MPLS VPN, I will teach you that why is it necessary to allocate RD value. But right now, just try to think that if we are going to call VRF into your BGP, then it is necessary to configure RD value, route distinguisher, which means to differentiate your prefixes. So because I'm gonna to call this IBM for BGP, so I'll say that IP VRF for IBM, and then RD will be allocated in this format, 16 bits colon 16 bits. You can allocate anything like 1:1. Just come outside and then go to router BGP 100 you can say no default, no BGP default IPv4 unicast, right? And then you have to define your router ID as well, otherwise it won't be possible for BGP to pick router ID because there is no interface which is working in yes. So do one thing, say BGP router ID and then create one address family IPv4 for VRF what IB and now configure your neighbor is what 30.1. Remote AS is what 655. Then one another neighbor is also existing 40.1.2 and remote AS is also what 65500. In this case now you will not require to perform redistribution right anywhere because the prefixes can go from BGP to BGP without any problem, right? So in this way you can configure your neighbor and then after you do one thing, move back again on IBM site A and say router BGP 65500 and neighbor will be 30.1.1 and remote AS is going to be 100. Say redistribute connected just to advertise all prefixes into BGP, right? In same manner I will move on IBM site B and say on site B I have configured it actually. On site A now I have to configure it. Router BGP 65500, neighbor is 430.1.1, remote AS is what 100, redistribute connected. I have to modify the configuration of site B. In place of 30 I have to configure neighbor 40.1.1, remote AS is what 100. Neighborship must come up now. You see neighborship have came up now, right? And now they must be able to exchange their prefixes, but they won't. Why? Because they will find actually prefixes coming with same as. Show IP BGP. Let me show you. Just wait for a moment. On site A you will not be able to get the prefixes coming from site B, and on site B you will not be able to get all those prefixes coming from site A. You see, are there? Even you can say debug IP BGP updates and then you can say clear IP BGP star in. What is it saying? Right? So do one thing, router BGP 65500, you can say neighbor 30.1.1 allow AS in. And in same manner you will move on site B, and on site B also router BGP 65500 neighbor 40.1.1 and then allow AS in. Show IP BGP. Let me show you now. All of them have came now. You see. Check it out. But even it have started now to receive its own prefixes as well from the neighbor after doing this configuration, right? Move on IBM site A as well. Check it's on BGP table now. Right? It have received them now. Show IP route. Check it out. And now you can try to ping with, even when your source is your own, even you can take telnet of that. This is called VRF lite. So you can see that by default traffic can move from one VRF to another VRF, and even routes were not going from one VRF to another VRF. So now you are not required to have a separate hardware device, hardware router. I mean separate router for each customer to separate their prefixes, to separate their traffic, right?
What is it possible to communicate between two VRF? So by chance if this Cisco purchase this IP.
Layer 3 VPN, MPLS VPN. Don't worry about that. That's not possible without MPLS VPN. Right, guys? So in this way you can do this, and you see, if you want that, okay, Cisco side should be able to communicate with IBM side, do one thing, just interconnect these two routers together. They are not using VRF, they can exchange their prefixes with each other, because this time they are using same prefixes, so it won't be possible. The very first thing, that if you are going to establish communication in between two different VRFs, make sure that all of them, all VRFs are using separate prefixes, different prefixes, and then after you can try to think about that. Because if they are using same prefixes, then how can you do that? There will be subnet overlapping. Is not it? So I hope that you people have understood that how can we configure this VRF Lite. What is the advantage of having VRF, right? How can we implement it?
पैकेट में कोई चेंजेस होता है?
Nope. Nothing. Nothing. Only IP header, Ethernet header, that's it. But the only thing like which is changing now, that if you are receiving your packet onto that interface which is member of the VRF, then it will perform lookup in that VRF only, and accordingly it will take decision.
VRF Lite क्यों कहते हैं?
Because you are not implementing MPLS. Yesterday you were absent. Yes.
एक राउटर पे कितने VRF क्रिएट कर सकते हैं? एक राउटर पे कितने VRF क्रिएट कर सकते हैं?
It's up to you. There is no limitation. Respect to VRF, right? So finally on R3, I have created this diagram now. Fine, move on R2 back. Let's move back again on R2. Say IP VRF is what? CC IE. Then go to FH0 by 1 and then say IP VRF forwarding is what? CC IE. Then allocate your IP address once again, 23.1.2, right? So now you see show IP route. This 12th network is in global routing table because this interface is part of global routing table, right? Whereas show IP route VRF, and you can say CCIE. This 23's network is part of VRF CCIE, right? And now you have to ping from R1's loop back to the R3's loop back. So on to R2, you have to take your traffic from global routing table to VRF and back from VRF into global routing table. You understand? So I will achieve it with the help of static routing, and I'll go through the concepts only. First of all, R1 must know that how to reach 333. Does it have any route? Any route to reach 333? So say IP route 3333, and next exit interface is going to be FA0 by 0, next hop will be 12.1.2. Any problem? Try it out. So now R1 has this information that how to reach 333. Finally it will give this packet to R2. R2 will receive it on F0 by 0, right? So now because on R2 F0 by 0 is part of global routing table, so it will perform lookup in its global routing table only. Is not it? Because F0 by 0 is part of global routing table. So does its global routing table has any information about 33333? No. So you have to say IP route 333 245 245 245 245. Exit interface is going to be 0 by 1. That's enough. You can do this configuration. But remember, you have to specify both of them, exit interface as well as next hop address. It's mandatory. If you are taking your packet from global routing table into VRF, then it is mandatory, right? It's mandatory to configure it in this manner. So this time its global routing table has this information that to reach 3333 it has to go out from FH0 by 1 and next hop address will be 23.1.3. Finally R3, I mean your packet will reach R3. Then it will respond back to 1111. So it must have that how to reach 1111, right? So IP route 1111 FA0 by 1 and then 23.1.2. Right guys, so this time it is having that information that how to reach this 111. Now packets will be received on R2's FA0 by 1 and this interface is member of VRF CCIE. So it will perform lookup in its VRF CCIE to reach, tell me, 1111. Does its VRF have this information that how to reach this 111? You have to add this route now inside VRF, and to add static route inside VRF, this is your command IP route VRF and it is CCIE and then 1.1.1 245 exit interface is going to be FA0 by 0, next hop will be 12.1.1 and it is part of global routing table. Means this next hop and exit interface is part of global routing table. So now we have added this prefix into its VRF. I mean we have added this static route into its VRF, right? So now if you check its routing table for this VRF, so IP route VRF is what? CCIE. You will definitely find that 11111, right? And then finally it will reach, I mean your packets will reach back this R1. So try to ping with 3333. You will not be able to ping with 333 because by default exit interface will be 12.1.1.1. Now R3 doesn't know that how to reach this 12.1.1. So in source you have to put your on loopback 1. So this time see, any problem? Even you can take telnet of R3, you can move on R3 and then you can say enable password is Cisco line VTY02 for password is what? Cisco, and then you can move back again on R1. Say telnet 3.3.3 when source interface is loopback 1. Otherwise telnet will not be successful. It's not it. So in this way you can take telnet of your device. So in this way you can take your traffic from global routing table back into VRF and from VRF back into global routing table. Understood? So this is how that you can configure static routes in your VRF. Is there any problem now? Have you understood VRF Lite now? So VRF Lite is just to use VRF without using MPLS. So we didn't enable MPLS onto any interface, did we? So that's called VRF Lite. So I have taught you that how to configure EICRP, how to configure RIP, how to configure OSPF, how to configure BGP for VRF Lite.
So only with static routing is it possible to communicate functions, or even we can use some dynamic routing?
Nothing. During MPLS VPN I will let you know some other things as well, but for now there is nothing like that, right? So I think that's enough for today, right?